electricity is what it is it? What I writing here, it is study of charges. Okay, as you earlier in 9th standard you have studied the charges, like in an atom there is a nuclei, and a part of that is a proton, neutron and electron. So many charges you have earlier studied in class 9. So what I mentioned here, that is a study of charges. Okay, so study of charges is what defined as electricity. So here we are going to study the charges. So what is charges? What type of charges we are going to study? Here there are two type of charges. The first one is steady charges and it is your current charges. Okay, so what is steady charges and what is current charge, and what is the basic difference between these two terminologies? So steady charges are those charges which are in rest, It means that the study of charges of those which are in rest. Like an example, earlier we have take a insulator like a plastic scale and rub on our hairs and just put it some small pieces of small pieces of papers and just attract these papers from this scale. It is very easy, and we are playing at when in our childhood days. So it is what? It is a static current, static electricity. That is, the charges are in rest. There is no any kind of movement on charges on that. So that is the part of static charges. Here in 10th standard we are going to start the current charges. What is the current charges? These all charges are moving. These all charges are moving from one place to another place, and that is your current charges. So as I mentioned here, the current charges are those charges which are moving from one place to another place. So study of charges, I write here first, study of charges at rest, and second point I mentioned here, the study of charges at motion. Okay, so study of charges at rest, it is called your what? The steady current or steady charges, and study of charges at motion, that is your current charges or your current electricity. Okay, current charges or current electricity. So now I mentioned here, that is your steady and that is your current, steady and current. Now what the places where this steady charges is going to be happen? Okay, the basic thing is this: we have to understand the concept of flowing of charges from one place to another place first. Why I am going to just focus on charges first? Because of all, you know that where it is possibility of charges to flow, in what place it is going to be flow. Like if I am going to say you a conductor is a best way to flow of charges. No, somehow there is a liquids, there is a solid and there is a gas. All the way we can flow the current in other manners. But in 10th class we are going to only focus that to study the charges of motion in conductors. Okay. So before I start the things, if I am going to discuss you the thing that is your charges, I can say that it is a electric charges. That is your electric charges. What is this? How many type of charges are there, and what is the notation of these charges? So many things are there. So step by step we can analyze the things and we can discuss in here only. Okay, electric charges. Basically electric charges is denoted by capital Q. It is denoted by capital Q. Now there are two type of charges, as we all know that there is a positive charges and there is a negative charges. Okay, there is a positive charges and negative charges. But if we talk about the current electricity or charges in electricity, we deal with the negative. We deal with negative charges. We deal with negative charges. Okay. So now, what is electric charges? What is the definition of electric charges? If someone is asking us what is the definition and what do you know and what is the understanding of that particular the thing that is electric charges. So electric charges is not an element. Electric charges is not a something that it is a property. It is a property. So we can say that electric charges, it is an intrinsic property. It is an intrinsic property. What meaning of this term intrinsic? Intrinsic is mean that it is an internal property of anything. You can imagine that any metal, any non-metal and anything. So it is an intrinsic property. So basically it is invented by the scientist name is Coulomb. So it is represented by the Q and basically its symbol is, if I am talking about its symbol is capital C, because it is invented by coulombs. It is invented by Coulomb. So it is represented by C. Okay. Or we can say that its SI unit is Coulomb. Its SI unit is Coulomb. You all know that what is SI? It is in standard international. Okay. So SI unit of Coulomb is SI unit of charge is Coulomb. Now, if someone is saying that, like, what is the smallest unit of this charges to be? What is the smallest unit of this charges? So earlier what I discussed to you, in electricity we are dealing with only negative charges. So this negative charges, the smallest unit of a charge, what I am writing here, smallest unit of electric charges, or we can say that charge, that is E and minus. It is the notation of what electric charge is, that is negative. It is e to the power minus. Okay, just it is a notation. It is defined as 1.6 cross 10 to the power minus 19 Coulomb. You have to make sure that you have to remember this figure, that is 1.6 cross 10 to the power minus 19 Coulomb. Okay. So the smallest unit of electric charge is what? 1.6 cross 10 to the power minus 19 Coulomb. Now, how many electrons are moving from one place to another place? Like one electron, like two electrons, like three electrons. It is a multiple. So it is defined by quantization of charge. Quantization of charge. Okay. So what is this new terminology? Is quantization of charge? Like how many charges? How many electric charges? Like one smallest unit of one charge is what? 1.6 cross 10 to the power minus 19 Coulomb. So how many electric charges are moving? Like 2, like 3, like 4, like 5. So this quantization of charge is defined as Q equal to N dot E. What does it mean that? Q equal to N dot E. N is numbers like it is 1, 2, 3, 4, 5, any number. And E is what? Smallest unit of electric charge is 1.6 cross 10 to the power minus 19 Coulomb. So if someone is saying that two electron charges or two charges are moving from that place to this place, so you can hear 2 into 10 to the 2 into 1.6 cross 10 to the power minus 19 Coulomb. Okay. So Q is equal to N into E. What is this? It is a quantization of charge. Hope this is clear to all of you. What I have discussed here in 10th standard, the chapter is electricity. In electricity, we are going to study the charges. What type of charges? Electric charges, we are going to study that. It is a negative charges. Okay. What I discuss here, study of charges at rest, it is called study. And study of charges that are in motion, it is called current. So we are going to discuss this particular thing in this class 10 electricity. Okay, so hope you all are clear that what is the basic concept of this charges and what is the particular need to study these things. Okay, now furthermore, if I am going to discuss some detail of that, what we are going to need to flow our charges, what we are going to need, the basic this somehow is saying conductor, as I earlier told you. So what type of conductor we have to use? Okay, so conductor is that is the property to flow the electricity is called what? Conductor. Now why? Okay, conductor, I can say that it is a metal or non-metals. So why metals are good conductor of electricity? What I am writing here? That is why metals are good conductor of electricity. Why metals are good conductor of electricity? We can use non-metals also. So what is the basic difference? Or we can say that the thing that is any material to be a good conductor, any material to be a good conductor is that to allow the flow of free charges. Okay, what is the good conductor? To allow the movement of free charges. What I writing here? Free charges. Okay, so what is free charges? As I earlier told you that in 10th standard, if charges are come in figure, so negative charges we are going to study. And what is the negative charges? It is electrons. So what is free charges? If I take an example, like if any kind of atom you have, okay, it is a nucleus portion and here this is a cell, okay, and we all know that is a 2, 8, 8, 18, the configuration of basically the electron what we are making. So if electron is putting in the outer cell, okay, the electron is putting in this outer cell, this electron is free to move. Like NaCl, the bonding of the electrons. So this electron is free to move, like free to share, like free to make bonding to another element. So it is a free charge. That is what? Free charge. It is called free charge. Now why metals are good conductor of electricity? Why non-metals are not? So again I took an example, that is if I am talking that metals and non-metals. Okay, so metals are those who's having a large atomic structure as compared to non-metals. It is a basic things. Like if I am talking about the metals, so metals is configuration like this, and if I am talking about the non-metal, so it is in a smaller size as compared to non-metal. I emphasize that word, it is compared to metal. So this size is large and this size is small. Now the electrons, or we can that the free charges which are moving in this outer cell, or electrons are putting in this place also, and if the electrons in this on so on. So why metals? Like as we all know that the distance between this nucleus to that cell, that particular this electron, this free charge is quite longer. So if the distance is long, the intermolecular force is quite weak. It is not the capability to grab this electron for further. So what it does, if the small heat is getting, it is free. If the small heat is getting, this electron is going to be free. But if talking about the non-metals, the distance between this electron and this nuclei is quite small, so what happened, if distance is quite small, if you are going to make the more heat or more any kind of putting it is this in room temperature, it is not going to be like make free this charge quickly. So we are not using non-metals. Okay, so we are dealing with only metals like copper. As you all know that in our domestic electric circuit we are using only that is your copper wire, aluminum wire, and so on the things. Okay, so the concept is clear. Why metals are going to be good conductor of electricity? The size of an atom, not non-metal. Okay, now the important thing is this, that is our again a new topic. It is that electric current. Electric current. Okay, no doubt. Okay, we are going to start with electric current. What is electric current? In a simply way we can I'm writing here, it is rate of flow of charge. Rate of flow of charge. It means that basically electric current is defined as capital I, and I is equal to Q upon T. Q upon T, where Q is what? Charge, and T is what? Time. Q is your charge and T is your time. Always take the SI unit of charge, what I mentioned, it is coulomb, and if I am talking about the time, that is your in seconds. So I equal to Q upon T. Now what is rate of flow of charge? What does it mean that? Like if I am taking an example of a conductor or a metal copper wire, charges, like as I earlier told that an atom, these all are atoms, and all atoms have some free electrons or free charge carriers to move from one place to another place. So charges flowing per unit of time. It means that in a less interval of time maximum charges are flowing. It means that if the time is less, charges are more, then the current will be more. So I equal to Q upon T. It means that if time is less, charges are quite higher, so current will be high. Take an example. If I am going to say you like make a circuit, no, I am not going to discuss any kind of circuit here because you are going to be confused. Like 10 coulomb of charges are flowing in a circuit for 20 seconds. So what will your current? Q upon T, that is 10 upon 20, it is 0.5. Okay, so 0.5 ampere. Okay, I am telling you what is ampere. Now again I took an example, like 10 coulomb of charges, it will take 10 seconds to flow. The same charges, the time is less. Now what is the current? I equal to Q upon T. Q is what? 10 coulomb upon 10 second, that is 1 ampere. So you can easily see, you can easily take a look that what if the time is less, here time will be taken as 20 second and here 10 second. The time is less, current is higher. Now you all know that the rate of flow of charge is what called this current. Now again it is SI unit of electric current is what? Is ampere, because in some around 70s it is invented by Andrew Mary Ampere, so it is defined by the name of that ampere. Okay, so it is the SI unit of electric current is ampere, and basically somehow in quickly we are writing like it is ampere. Okay, and the measuring device, there is a physical device measuring the device a device which is going to measure the current in circuit is what? Is ammeter. Why again I am emphasizing this term ammeter? Because frequently it is going to be used in electric circuit. So you have to aware that terminology, that is ammeter. A device which is going to be measure the current in a circuit is called what? Ammeter. Now you all have to, I think the concept is going to be like short, is going to be like clear that what is electric current? I, we can define by the I is equal to Q upon T, the rate of flow of charge it is denoted by Q, time is S, it is in seconds, time T. So I equal to Q upon T, and earlier what I know, the quantization of charge, that Q equal to N into E. So we can make another definition like N dot E upon T is also a current. It is also a current. Now, what is the possibility to flow and what is the mechanism? As the student of science, we are all have to worried about why this free charges and how, why and how, these two words is going to be frequently asked in your inner side, that is how these electrons are moving and what is the possibility and which direction it is moving, from this direction or that direction. So now we are going to be discussed in our next term. So this is very important thing. I took an example again, a conductor or a metal. I took a copper metal, and these copper wire having atoms. I took, this is the atoms of copper, these all are the atoms of copper, and these all atoms have the free charge, and this free charge is electrons. This free charge is what? Electrons. This free charge is what? Electrons. Now, if these charges are free, so they can move. It's a property of it is a property of the matters. The free charges are moving. So, in what direction it is moving? The direction is random. These electrons are moving somehow in this place, in this, and that, and this, and this. It is the motion, or it is the way where the electrons are moving. Now, if the electrons are moving in random direction, so is there any kind of possibility that we can flow the current? I think so, no. There is no possibility to flow the current if the motion of these all electrons are random. So what we do next? We are going to add these two terminals with a cell. We all know that cell having two terminals, positive terminals and a negative terminals. I connected these two terminals of this wire to the electric. This we are going to be connected as cell. It is the positive, the longer one is positive and the smaller one is negative. As we, in further classes I am going to discuss why this cell is to be going like one is plus terminal and one is negative terminal. In further classes we are going to discuss. Now listen carefully, why and what happened now if making here a switch, it is a closed switch. I am just going to be discuss again later what is this is notation. It is a switch. If we going to on the switch, what happened next? It is that if this negative terminal goes in this side of that, this electrons is going to be repel. It is the property of the charges. The positive one is going to be repel and the opposite charges is going to be attract. The same charge is going to be repel and the opposite charge is going to be what? Attract. Now in this side, this negative charges hitting this, and these all electrons are getting a right direction to move. Like these, which electrons are moving randomly from one place to another place. So these all electrons are getting one exact what? One direction. These all electrons are getting one direction. So now these all electrons are moving from this place to that place, and now what? It is a positive terminal and these all are having the positive one. So these electrons are attracting this positive and these are going to be repel. So all of these we know what is that? It is make a difference. It is make a difference from this place. This cell is producing a difference, and this difference we are going to be study in our next topic, that is electric potential difference. Okay, so now these all electrons are moving from this place to that place. So as it is a funda that the electrons are moving in that direction, in whatever the direction it is moving, somehow there is a question rises in your mind that if we are going to change the terminals of this one, like that is a positive and it is a negative, so the direction of electrons is going to be made in that way. You are not going to be confused. Okay, as a student of science, I am telling you how and why. Two words always rises in your inner side. Okay, so why it is going to be happen? If I am going to change the polarity of this cell, what is going to be next one? So if I am going to change the polarity, these all our electrons are moving in this way. Okay, now in the direction of electrons moving, the current is always moving in that opposite direction. Again I am telling you, if the current are moving from left to right, then the electron are moving from right to left. It is somehow, it is a concept, or we can say that it is a funda. So we cannot emphasizing these terminologies why it is going to be happen. It is just recall the things. If the electrons are moving in this direction, then the electric current is moving in this direction. Okay, so as in a common general basis, we can understood that current is always flowing from, it is an electric bulb. It is an electric bulb. I can again mention earlier that the things. So current is always flowing from higher level to lower level. It is a basic concept. If we taking the hot body and cold body and just going to be attached these two terms, so the energy will always transferred from hot body to cold body. It is a natural phenomena. So we can say that the current is I is going in that direction, or it is a clockwise direction. So current is always in a circuit, current is always flowing from positive to negative terminal, and electric charges is flowing, that is electrons are negative to positive. So this is the basic thing. So you have to keep this thing in mind that electricity, current is always flowing from positive to negative terminal of any source, any battery and any circuit, and electrons are moving inside that circuit is that the opposite one. Okay, so now too much things are going to be discussed here now. Okay, if I am going to plot a basic diagram of an circuit, before I am going to start a circuit, I am just going to be discuss few things which is important to you all. That is, it is a notation of cell. It is the notation of cell. Okay, cell is having a positive terminal and negative terminal. So it is a cell, and combination of cell, it is cell or combination of cell is called battery. Is called what? Battery. Combination of cell is called what? Battery. It is cell, it is battery, and it is the term, again we will discuss later. It is voltmeter having a positive and negative terminal. It is what? Voltmeter. I am telling you that discuss earlier. It is ammeter. Ammeter is a device which is measuring your current in a circuit. So it is what? Ammeter. Okay. So few things are here, and electric bulb is making in this way. It is an electric bulb, and a very important term, that is resistance. It is going to be, we are going to be play so many numericals on the basis of that resistances. Few next classes we are going to be discussed, not now. So it is a notation of resistance, and it is denoted by capital R. And the next one is variable resistance. Variable resistance, you can vary the value of resistances. So it is this way. It is what your variable resistance. So few things are what I written over here is to be keep this thing in mind. Now I am just going to, you can just pause the video and note it down in your copy if you find some important things. Like I am going to make an electric circuit. So basically there is a bulb and ammeter. Ammeter is always connected series. Ammeter is always connected series in a circuit. Like if I am connecting a bulb, then I am going to connect an ammeter in this way. It is an ammeter, and here a battery, here a switch. Oh sorry, I didn't mention the open switch and closed switch. If it is your open switch, and it is your closed switch, open switch and closed switch. Somewhere in other books it is mentioned in this way also. It is open switch and it is closed switch. So you can use any one of them. I am here using in this way. So it is a positive and negative terminal, or what I discussed, current is always flowing from positive to negative. So current is flowing in this way, and this positive terminal is capped this ammeter as positive. It is an electric bulb, it is a switch, or we can denote it by switch is K. So this is the basic circuit. The very important thing is this: in 10th standard, in 1 mark question or 2 mark question, it is frequently asked in objectives and filling the blanks. Ammeter is connected in circuit in parallel or series. So here you can take a look that ammeter is always connected series in that circuit. So what I am going to write, ammeter is always connected series in circuit, always connected in series in circuit. Okay, so I think today we are just going to be just pause our classes, and the next one we are going to be discussed, that is electric potential and potential difference. Okay, so before I am going to pause my class, I just took an exercise question to all of you. That question I have been taken by your NCERT book. So that question is telling me that a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charges that flow through the circuit. It means that what the quantities we have given, the given quantities are like current is given. So I is equal to 0.5 ampere, 0.5 ampere. And now the next one is an electric bulb. It is blowing, or it is like the current is passing through this bulb for 10 minutes. So our time is 10 minutes. Now you have to keep the thing that is in mind, that here it is minute, the SI unit is what in second. So we have to convert this 10 minutes into seconds. So it is 10 minute equal to 10 into 60. So how much? It is 600 second. 600 second. Now what is asking? It is asking find the amount of electric charges. It is asking what? Q charges. So we know that I equal to Q upon T. I equal to Q upon T. Here Q is the charges and T is time. It is an electric current. What is the current is passing through from the bulb is 0.5 ampere. Now, can I write this equation in this way also? Q equal to I into T. Okay, no problem. I is how much? 0.5 multiply by 600. It is around 300 coulomb. So the amount of charge is what? 300 coulombs. 300 coulombs. Okay. So thank you so much. So for watching this video, and tomorrow or the next class we are going to discuss the electric potential and potential difference. Thank you so much.